In this lecture, we'll solve the problem where in a capacitor a liquid material is placed. This is a liquid material with the dielectric constant K is the dielectric constant. We should remember some basic things. Whenever in a capacitor you place a dielectric, if there is a charge density sigma here, let it be minus sigma and plus sigma here, then minus sigma p, that is polarization charge, and plus sigma p, just the opposite. If it is plus, it is minus. Here it is minus, this is plus, and the value of sigma p is equal to sigma 1 minus 1 upon k, where k is the dielectric constant. So this we should remember. Now here suppose the charge is minus q on the plate and plus q on this plate. Now the dielectric will acquire charge plus sigma p here and minus sigma p here because of these charges. Now let us find out the forces which will be acting on this top part of the liquid. Now let us take this top part of the dielectric. The force which is acting here is, let us say, because of this layer. Though it is meeting, we could have taken a combined effect of these charges, but let us do separately. Because of minus sigma charge on the plate and this negative charge, the charges are same, so it will be force upwards. So one F1 will be acting on it, and F1 value will be the electric field sigma upon twice E0. I am not taking the sign here because I have already taken the direction. Don't do both the things. If you have taken direction because of the signs, then don't put signs here. And the charge total here on this surface is A times sigma P. Please remember the electric field due to the plates, two plates, or the surface of the dielectrics is sigma upon twice E0 due to the plate, and due to the dielectric this is plate, and due to dielectric it is sigma P upon twice E0. These are the electric fields due to the independent surfaces. If there is one surface of the plate, this is the electric field if this is plus sigma, and if it is plus sigma P, again there is electric field. So direction I have already taken here, so I don't put the charges sign here. So F1 is sigma P A upon twice E0. Now what is the other force here? Other force, let us take what is the effect of these layers of the dielectric on itself. This force because of the dielectric layer here, which has plus sigma P, will be downwards. So F1 is upwards, F2 is downwards, and its value will be equal to sigma P upon twice E0, that is the electric field, and the total charge A sigma P, which is sigma P square A upon twice E0. This is upwards, this is downwards. Now which is the other force? The other force is, this is F1, this was F2, and there is another force which is F3. F3 is because of the upper plate, and because this is positive charge and this is negative charge, there will be attraction, so I have taken the direction of force upwards. Since I have taken the direction of force, I don't put the sign here. The field is sigma upon twice E0, and the charge is A sigma P. So now I add them algebraically. F1 plus F3 minus F2 is the net force upwards. So let us see how much is the force. It's sigma P A upon twice E0, and what is F3 is sigma P A upon twice E0, and F2 is sigma P square A upon twice E0. We take A upon twice E0 common and also sigma p as common. So we get twice sigma minus sigma p. This is the net force, and let us put the value of sigma p is sigma 1 minus 1 upon k. So we will get net force here is A upon twice E0 sigma 1 minus 1 upon k, and this will be twice sigma minus sigma plus sigma upon k. So it is A sigma upon twice E0 1 minus 1 upon k, and it is 1 plus 1 upon k and sigma again. So the net force is equal to A sigma square upon twice E0 1 minus 1 upon k. This is whole square. This is the value of the force net, and this net force which is acting, like if you take it again, the net force which is there on this dielectric is able to lift the dielectric by an height h. And what is the weight within this height? If you look at it in three-dimensional, this is the dielectric and this is the height. So what is the weight in this region? The total weight is the area times the height, area times the height, which is x, which is the volume, and density makes the mass, and g makes the weight. So A x rho g would be equal to A sigma square upon twice E0 1 minus 1 upon k whole square. So we get A gets cancelled, we get x is equal to sigma square upon twice E0 rho g. We can write this k square minus 1 upon k square. If we multiply both by side down and above by a square, we get x is equal to q square upon twice E0 rho. This is slightly, this will come here, and we get q square upon twice E0 rho g a square k square upon into k square minus 1 is the value of the height. So this is your answer.